In this tutorial we will be learning about quantum chemistry and VQE. On a quantum chemistry we can make Hamiltonian using Pauli operators and solve it using VQE. On a chemistry the advanced research on ansatz is done better than other problems and many researchers are working on this problem. Now to implement the code. Install Blueqat by !pip installed Blueqat. Click on Run button to install. After installing Blueqat we need to install OpenFermion Blueqat. Type !pip3 install OpenFermion Blueqat. Click on Run button to install. Here we use a prepared data provided by OpenFermion. Firstly, import Blueqat. Import OpenFermion. Import OpenFermion Blueqat, and finally, import NumPy as NP. Using molecular data function on OpenFermion, we can use prepare data of STO-3 grams on H2 molecule. Click on Run button. After that you will get output as this graph. Here we select 0.4 as the bond length between atoms. We get a formulation on second quantization. Click on Run button, and we will get this output. Bravy-Kitaev transformation or Jordan-Wigner transformation are famous. Now we use the former BK transformation. Click on Run button, and we will get this output. Now we got a Hamiltonian with Pauli operator, now we can solve it with VQE. To solve this efficiently we use UCC theory on ansatz. By using a prepared UC consatz in Blueqat we get. Click on Run button, and we will get this output. After the optimizing process we get the minimized result. This time we use UCC ansatz with Hamiltonian. Click on Run button, and we will get this output. Again we will do this for the whole code for H2UC consatz. We will import Blueqat, OpenFermion Blueqat, and finally NumPy. Using molecular data function on OpenFermion, we can use prepare data of STO-3 grams on H2 molecule. Click on Run button, and we will get this output. Thank you for watching this tutorial.